Okay, so in this problem, we're told that Donna wants to make trail mix from almonds, walnuts, and raisins, and she wants to mix 1 part almonds, 2 part walnuts, and 3 parts raisins. So, remember that well, maybe you don't know this, but baking and parts in baking, that's a general term, right, for a unit, because we don't know what the part is. In other words, when you say 1 part almond to 2 part walnuts and 3 parts raisins, that just means that, well, however many almonds you have, it could be a cup, a pound, a ton, whatever, you have twice as many, 2 cups, 2 pounds, 2 tons for walnuts, and 3 times as many for raisins, right? It could be 3 cups, 3 pounds, 3 tons of raisins, right? So here, that ratio between almonds and walnuts and raisins is set up so that, for any unit measurement, we can use this formula. And if you notice, in the next sentence, they say almonds cost $12 per pound and walnuts cost $9 per pound and raisins cost $5 per pound. Here they're setting up our parts as pounds, so you can reread the sentence before it as in she wants to mix 1 pound of almonds, right, with 2 pounds of walnuts and 3 pounds of raisins. That's one way to look at it. But if you read further in the question, what's fun about this one is they say, well, she only has $15 to spend. How many pounds can she make? Well, here when you set up the equations to deal with this problem, I think what's really important is to think, okay, well, whatever number of almonds I'm buying, right, and walnuts and raisins that I buy, she only has $15 to spend. So we can think of this as an inequality where the amount you're spending has to be less than or equal to $15, right? Because we can't obviously buy more than that. So we don't know how many pounds we're buying of each type of, of nut or raisin here, like of each ingredient for the trail mix. We don't know how many pounds we're buying. We just know how much they cost. So what we do know is that almonds are $12 per pound. So maybe A is the amount of pounds of almonds we're buying, and 12 is the cost of each of those pounds. While walnuts are 9, so W would be the amount of pounds of walnuts, and raisins is $5 per pound for raisins. So R would be the amount of pounds of raisins. Now it seems like you can't go any further here because you really, you have one equation or inequality, however you set this up, and you might feel overwhelmed. But remember that original statement saying, okay, well, whatever the number of almonds that we have, there's going to be twice as many walnuts. So we can think of the walnuts as twice the number of almonds, and we can think of, so this would be walnuts right here, and we can think of the raisins as 3 times the amount of almonds, right, for raisins. So what we just did there is think of walnuts and raisins in terms of almonds, and that will allow us to finish the problem. So here, the inequality, 12 times A, instead of 9W, we can write 9 times 2A. Because here, W is the same thing as twice A. Why? Because the amount of walnuts we have, whatever amount of pounds that is for the walnuts, we have twice the amount of pounds of, it's twice the amount of pounds of almonds. So whatever the walnuts are, it's twice the almonds. So W equals 2A, we can substitute. And then 5R, well, instead of 5 times the raisins, well, it's 5 times 3A, because the amount of raisins would be triple the amount of almonds. And this is all less than or equal to 15. So this is a good problem for substitution, because now instead of 3 variables, we have 1. So we have 12A plus 18A plus 15A has to be less than or equal to 15. We add these up, 10, 20, 30, and then 8 and 2 is 10 more. That's 40. It's 5, so 45A is less than or equal to 15. So let's keep going up here. So if 45A is less than or equal to 15, we divide both sides by 45. And what do we get? Well, 15 over 45 is 1/3. So A has to be less than or equal to 1/3. Cancel out the 45s. Now we're trying to buy the most we can. So I'm going to see, well, if A equals 1/3, that's the most almonds we can buy, then the walnuts would have to be less than or equal to 2/3, and the raisins would have to be less than or equal to 3/3. Now, here we're trying to find out how much she can buy. Well, If you notice that since the almonds are less than or equal to 1/3 and walnuts are less than or equal to 2/3 and the raisins are less than or equal to 3/3, that means the highest amount of almonds, walnuts, and raisins we could buy is 1/3 for almonds, 2/3 for walnuts, and 3/3 for raisins. And that's what we want to do because we want to buy the most that we can. She wants to spend all of her money on this. So that just means that we're going to have 1/3 of a pound of almonds, right? So in fact, we can say how many pounds of trail mix is she going to buy? Well, okay, or can she make, excuse me. So the almonds would be 1/3 of a pound, and the raisins would then equal, well, sorry, walnuts are next. Walnuts would be 2/3 of the pound, twice that, 2/3 of a pound. And raisins are 3/3, or, for R again, sorry. Walnuts are 2/3 of a pound, and raisins are 3/3 or 1 pound. So we basically have 1/3, 2/3, and 1. That's a total of 2 pounds, right? And that's the most she can buy. So just to recap again, what I first did was think of almonds and walnuts and raisins as representing the pounds of those ingredients. And then these numbers 12, 9, and 5 were the cost of each of those ingredients. And then because I know we can't solve for A, W, and R without having 3 separate equations, what I did do is write W and R in terms of A. So if almonds, whatever amount of almonds we have, we're going to have the walnuts will be twice the almonds and the raisins will be 3 times the almonds. So that from there we can solve for the almonds and then use that to figure out the rest of the measurements that we can buy. Then I bought the maximum amount from each category, and it has to be a ratio, an equal ratio to complete the recipe. So if we take the full 1/3 of almonds, we take the 2/3 of walnuts and the 3/3 of raisins, added them up, got the weight. Thank you.